Okay, the stream should be transferred over. Here is the agenda. If you are in the YouTube chat and you can hear me, let me know. People might still be trickling in. All right, cool. So first half, we will discuss anything related to Kintsugi and the merge, then go into any other client updates if we have them, then some general discussion, technical discussion about research spec and other things beyond the merge, and open discussion closing remarks at the end. Thank you, Alex, and thank you, Tim, for handling the couple of calls in my absence. I was off a lot of the last month, and in fact, I am still wading through everything and catching up, but I will get there. Let us begin. We can start with general Kintsugi updates. Is Perry here, or Raphael? Raphael and Perry. Hey, Perry. People are trickling in. The first thing on the agenda is just general Kintsugi testnet update. I see that we're finalizing. Do you want to give us a quick on that?
Sure. Yeah, after the issues caused by Marius's fuzzer, we were able to find quite a few bugs over the week, and the chain wasn't finalizing from last Friday morning till about yesterday evening. So essentially, we just pruned off a couple of the forks, made sure there's one major fork, and we have, I think, almost every client combination working. I think there was Nethermind Nimbus and Nethermind Prism or something like that that Marek said he'd look into and would reach out to the teams, but otherwise we seem to be good to go.
Cool.
And as a side note, I have a bunch of databases from the non-finalizing period. I will upload them and just share a drive link. There's also a dump of the proto array, I think a couple of log files, and yeah, there's quite a lot of debugging information in case people want to still dig into stuff.
Great. And I know, I'm always beating this drum. I know we've captured a couple of test cases from this. I think some more should be captured and maybe make their way into Hive or some sort of like environment that actually utilizes the engine API. Are we cataloging these anywhere?
Not yet, but I will start a document to do that. I wanted to work on a proper incidents report so that we have like a timeline for everything that went wrong. I guess that this is a nice candidate to tag onto that.
Yeah, that'd be
so Mario is already adding them to his PR for Hive.
Okay.
So the ones that we found.
Excellent.
I'd like to add here that this block hash issue partially appeared because it's not that clear from the spec that the block hash must be verified against the block constructed from received payload. There is a requirement for execution layer clients to verify the block structure, but in this particular setup, it's not that clear. I mean, in this setup with the separated CL and DL clients, it's not that clear how this verification should be done, and this is what's been changed to the spec. Also, which is even less clear is that this check must be performed even if the client is syncing, which is important.
Right. So the way that's going to manifest in a spec clarification, or I guess minor spec changes, like anytime there's an inserted payload, there's pretty much like a well-formedness check. You know, does the block hash map and maybe some other like minor things before even deciding to do syncing or whatever. And if it's not well-formed, it's invalidated immediately.
Right, and I think that any block header verification, including this block hash verification, should be performed if it's possible, if
Yeah.
there is enough data for it.
Should we already have to check whether this reverts finality there? Or should we have this somewhere else?
I suppose if so, the consensus layer client shouldn't be reverting finality, but if it were on a branch that you decided you should never execute because it was signaled as finalized and you did deep pruning, it does seem prudent to just say, I'm not going to do that in some way. So that might surface as invalid, but we should, I feel like that's a bit of an abuse of the semantics, so I'd like to think about it a bit more.
I suspect you'd get that every time you wipe the database of the CL and keep the EL running. Did it start again?
Right. But I guess so you can get a bunch of like weird inserts, even though CL presumably is probably going to get to the same result eventually.
Well, we check if we have this block in the database, and if we have it in the database, then we're maybe not going to perform this check.
Right, but if you had previously heard finality and pruned, then
we still know that we had this block at this block height.
Okay. Then the answer might just be utilize that cache to say it's valid. I don't know if you would want to tell it it's invalid.
Well, if it's known block, then we can just say it's valid, so that would be a no-brainer answer. If the question is what happens if we get actually a block that's older than our finality point. In that case, we've been discussing with Marius that we should just reject it with the assumption that it's some weird error in some client. And if the execution, no, sorry, if the consensus client tells us that, okay, here's a new finality, which actually entails rolling back the previous finality, then we could just say, okay, I'm going to sync. If you're really sure that this is where you want to get at, we could go back.
Right. But again, so if you still have the block from the block tree and knew that the actual execution was valid and cache that, you could still say the execution is valid, because you can get into these position, like if CL was resyncing, it might be giving you some stuff from before a finality point.
Yeah, definitely. So anything that is on the canonical chain, so if we get a replay of old events, those should be kind of accepted without modifications to our current chain. That would be my guess.
Yeah, that's what we do. We just ignore them. Well, we say inserted already known block and don't actually insert it. If it matches the hash and the and the block number matches.
You would also get a stream of fork choice updated from potentially Genesis on from the beacon, from the consensus layer. You probably don't want to roll back to Genesis, right. And then like ignoring that is probably reasonable, but it means your head isn't where the beacon thinks it is.
How can we ignore that? Like how can we know that these fork choice updated are just like replay?
Well, we can always check our current header chain, and if you just say, okay, fork choice update, if the fork choice is updating to something that is already in our canonical chain, then it's just a no.
Oh yeah, true.
Fork choice updated, sorry, can move backwards a small amount though. We might revert back to the justified checkpoint in some odd corner cases, I think.
You would never revert. So you say you have a single chain, you would never revert to earlier in that chain. It would have to be, the only reversion would be to a different chain, because you always end up on a leaf.
Yeah, that's true. Fair enough. So yes, if you could potentially, and we'd probably need to think it through a bit more, but potentially ignore fork choice updated that is going backwards on your existing chain, like to an ancestor of your current head.
Right.
If you said that the head of the chain is optimistic, you might, and it turns out to be invalid, you might go backwards. What it's worth.
Right, but
Might
that's
be easier to look at the finalized.
But that would never anything invalid would never make it into the EL canonical chain because it was invalid with respect to that layer.
Not if we snap sync past it.
Sure, I mean more in kind of the head range.
But the real giveaway would be that if the finalized hash is gone backwards, then it's definitely a replayed update. Like the head can be more complex, but finalized definitely should never go backwards.
Yes, and I think it's like if we ignore everything where the finalized hash is like going backwards, then we already have like, I don't know, 99% of all fork choice updates we can ignore then. And so it only like the period where we're in like this weird period between the last finalized one and the new, then that's the only issue, and that's not a big issue. So we can replay 64 blocks or something.
Yeah, most of the time that should be a small amount like that, and it's pretty common to kind of roll back that far. I mean,
it's pretty common on a
normal
testnet.
use, but yeah, not in terms of normal use, but in terms of syncing. I mean, I know clients earlier were routinely doing that on every restart, and you didn't notice until it went wrong when Madasha went wrong. But yeah, it's not an unreasonable number of blocks.
And once again, if we go backwards in terms of finality, it's going to be ignored, which is reasonable. But if it's like the other fork that is about to be finalized or attempted to be finalized, what's the behavior should be? Like the fork, like I don't know, the new finality checkpoint is on the on the other fork than the current one.
Well, if the finality just goes sideways, whether it's below or up or wherever, my assumption would be that, okay, the beacon chain reorgs to some different chain and we just follow it blindly. I mean, we just assume that that is a correct chain.
See, and then if you don't have like the state to execute those blocks, because it's
I would trigger a sync cycle in that case. So if the beacon chain client announces a new finality, which I don't know anything about, then I should just assume that, okay, I'm missing something here. I just need to sync it.
Right. So this is, I mean, you'd only expect such in, an exceptional recovery scenario in which maybe you had finalized something that was manually reorged, and so hitting an expensive sync is probably expected in such a scenario, and fine.
Yeah, so it's kind of like a fallback scenario, so that if, let's say there was a consensus error and some clients need to be swapped out.
Right.
I mean, the chain from underneath, some clients need to be swapped out, then it's healthier if there's already the functionality implemented and you don't need to. I mean, if the beacon chain says, okay, switch to this chain, it's nice if the execution client can just switch to it instead of you having to manually tell the execution client to switch.
Let's piggyback on this discussion. We'll do the testing discussion after and talk about what we've been discussing over the past 24 hours in the merge channel. So I think the TLDR here is really that this is not the case for all execution clients. I think Aragon handles things a bit differently, but the default is really that there's the execution client really only executes a branch in proof of work once the fork choice has signaled this is canonical. And so only when the difficulty of a branch overtakes the canonical branch would it actually execute such a branch. And whereas the semantics of execute payload and fork choice updated we're implying a bit differently to the execution layer. They're pretty much saying, I'm giving you a payload. It might be from any branch. It might not even end up being the fork choice or canonical, but you should execute it. And this mismatch in reality led to, when there's high forking on the beacon chain, very high load on Geth and probably other clients. So the semantics of these calls should probably be may execute on inserting a new payload to handle the case where such branches aren't to be executed until the fork choice comes, or clients where they can execute multiple forks at the same time, and then a must when the fork choice comes in. That's, I think, the initial discussions that have happened, but there's certainly something here to iron out because of the mismatch in expectations and reality. Peter.
Yes, so just wanted to say that currently Geth in proof of work mode, what we do if a block is broadcast, obviously the block just builds upon our current chain, we execute it and problem solved.
Right.
Now, if the block does not build upon our current chain, which would be the case here with the execute payload, we have two options. One of them is if we have the state for the parent, then we just execute as previously.
Right.
If we don't have the state for the parent, then we just stash away the block in the database and wait for total difficulty criteria to exceed it.
Right.
So something like that could be done here too. Whereas with execute payload, if I have the state, then I can just execute on top. And if I do not have the state, but I still have the parent, then I could just stash the block away and maybe execute it only when I get a fork choice update.
Right. So I think that we do have to modify the semantics of these calls to allow for that behavior in some way. And so execute, like I said, becomes a may. It's a must if it's the head. It's a must if, I guess it's a must if it's building on the head, really. And it's a may if it's on some side branch. And then it becomes a must when you get a fork choice updated, which is the equivalent of the difficulty of such a branch overtaking it. And there was certainly things to think through here. Because I think the semantics we have today do not really match the reality of that. Go on, Mikhail.
Yeah. In general, I agree with changing the semantics that would allow optionally to do the execution either on the execute payload or fork choice updated, whichever suits better for the particular client. I have a question to Peter. You've said that if you have this parent state and this is the side chain, you will execute a block, right? I'm just wondering what are the cases when you don't have the state to the parent? Is it like when you just like snap synced and there is a side?
Or is it deeper than one block?
No. So Geth maintains the state for the last 128 blocks. So if your new block is rooted within 128 most recent blocks, then we will have the state available to execute. If it's rooted deeper, then we will probably already have pruned the state, and we would need to roll back to some fairly deep checkpoint from which we could execute everything forward.
Okay. That's much better than I thought.
Yeah, that's much better.
That's a lot better than I thought based on our conversations the past 24 hours. Okay. That's good. I just I was assuming, if you were at a depth of more than one from the head, and you had these branches that you were really only maintaining the head state, and that was counter to what we had discussed months ago. But I was just I became confused in our conversations. Okay, that ends up good, and that ends up the change in the semantics ends up being a much more edge case than a normal case.
Andrew's got his hand up, and I suspect he has bad news.
Let's hear it.
Yes, so I'd like to say that for Aragon it's different. For Aragon, we don't support multiple states. We only have one state, and for us, any kind of reorg is relatively heavy. So we cannot simply like almost simultaneously switch between states. We have to do a quite expensive reorg.
Right. Okay. So even if I have just a 2-block depth at which the branch occurs, it's
well, it shouldn't be problematic, like, because the reorg will be fast.
pretty cheap.
So
Okay.
we have state diffs, so we have reverse state diffs. We apply reverse state
Right.
diffs
Understood.
to get to the common point and re-execute the missing blocks.
Okay. So in that paradigm, still changing this these semantics to be may unless on the head and a must when you do a fork choice updated. Tell me this, in proof of work, you would only do such a reorg when you get a signal that the difficulty is worthwhile on the side branch?
Correct.
Okay.
Yeah, correct.
Okay. So that, again, that's still, even though that's different behavior or different costs than Geth, that's still in the direction of the semantics we've been discussing.
Yeah.
Just wanted to mention that Geth is actually going towards that direction. So although we will still maintain 128 states always, so that's something we are going to keep, but we will be also implementing the reverse diff approach. So if, for example, you want to do a 10,000 block reorg, it would mean that we would need to apply 10,000 reverse diffs. But it's
Right.
still fully compatible with all the discussions here. So
Good to know. Can any other execution layer clients weigh in on the previous engine API semantics and the ones we're discussing and how that might affect them, or if this sounds kind of synonymous with how their client works? If no comment, I'm going to assume that that's generally kind of in line with how things work.
I have like last question with respect to this topic to Geth team. Once you have this reverse diffs, will you still going to maintain the several states?
yes.
Yeah. Okay.
Yeah.
Thanks.
So
I've just missed this. Okay.
So essentially, you could think about that we would have this persistent state on disk that's 128 blocks old. Any newer changes would be stored in RAM, in memory. So essentially, the latest 128 diffs would be in RAM, and you could have an arbitrary branching. And older diffs, then if you want to go back more than this 128 block old persistent state, then you would need to start applying these reverse diffs to mutate it back to where it was. But
Understood.
we would still make, I mean, SnapSync also relies on the state being available for the last 128 blocks.
Got it. So you'd have relatively cheap inserts in the 128 range, but you'd be able to do these deeper reorgs without switching to some more insane sync mode.
Yeah, so essentially anything that's shallower than 128 should be instantly executable.
Got it. So I do believe, based on the conversations that are 24 hours, we need to write down a modification proposal to the engine API to account for this, and model out the interactions on a normal and some of these edge cases.
Are we heading towards having fork choice updated return valid and invalid rather than just success, since it's now the must execute?
I personally need to think about it a little bit more. That does not seem like an insane design choice, but I need to think about the implications more. What do you think?
I'm leaning more and more towards doing it. We discussed it a bit, and kind of settled on, well, let's not change things. But I think if we're going to make a decent amount of changes, it feels like it makes a lot of sense to get the value there.
Right. If
one corner case is, let's say, in theory, it would be possible for me to feed, if I give you, let's say, 10 blocks, 5 of them valid, 5 of them afterwards invalid, and then I do a fork choice update to the head of these invalid blocks, then what would be the meaningful return? I mean, the chain setting the head is not possible because some blocks in there are invalid.
And so the meaningful return ends up being invalid, and that's maybe why the fork choice updated should be able to handle that, because on such a branch, I don't actually know if it's valid until I signal for you to execute it with the fork choice updated.
I'm just saying that there might be some weird corner cases.
Yeah, I agree. I agree. There might be some nastiness in there, and we need to be careful.
It's definitely worth more thought, thinking, and analysis. Yeah, but I'm also leaning towards having this execution semantics for both methods with respective response statuses and the respective behavior on CL side. So it will need to understand that the fork choice updated also may return with the execution statuses, and so finish syncing if it's appropriate in the current state, and react accordingly to the new statuses and new semantics.
Okay, so from this, Mikhail, myself, and some others will try to iron out a modification proposal and seek a lot of input and feedback on it, to make sure that we hit the edge cases and it works with EL clients. Peter?
Something just touching on this discussion. Do we have some form of infrastructure or capability in place to test these kinds of scenarios? I mean, these kind of failures that happened on Kintsugi.
Mm-hmm.
In essence, can we spin up a non-finalizing bad state? I mean, a network in a bad state, just to see what happens, what clients,
right?
What do client combinations do in this bad state?
So this is perfect, leading into our testing discussion. I do believe that Hive is approaching being able to do these types of things and handle multi-client combos. You can I guess I won't say it very easily, but you can certainly induce a non-finalized state by taking off 50% of the validators, and with a bit of extra care, you can create some partitions and some building of blocks on different branches. Light client, you've been thinking about this, right?
I have been thinking about this some. If there's any really specific scenarios that would be helpful, just let me know offline, and I can try and mock them out into Hive.
Yeah. So one thing that obviously comes to mind is don't finalize and build on at least 2 branches where the fork depth is 10, the fork depth's 100, the fork depth is 200, and make sure that you don't destroy the world by doing so. So that's one of the avenues. Other avenues would be there's some simulation testing going on with a company called Kurtosis. There's a desire to do some more live network scenario testing where we dynamically build out 100 node network, run a test for a day where you create partitions and do non-finality and things like that. So I think Hive is probably Hive and maybe Kurtosis are the closest to being able to do some of these things, but it's certainly critical to get that in there because we need to test all the client combos kind of continuously. On that front, I know there's a lot of parallel testing efforts going on right now. Are there any other things beyond some of the Hive scenario testing that we want to discuss today?
I don't know if this has been brought up before. I'm assuming somewhat yes. For example, there are certain orderings specified in the API calls that the beacon and execution clients need to adhere to. For example, before I'm saying, okay, before I'm sending a Fortress update to a certain hash, it is expected that I'm going to send an execute payload with that content.
Right.
And only after that tell you to reorder to it. However, my request or question is, what is the desired behavior in case of protocol violations? Now, yes, ideally, every beacon chain client, every execution client will follow the spec, but I think long term, it can be expected that certain bugs would occur or certain weak conditions like swapping out an execution client, swapping out a service client, even during runtime, and maybe that would result in these orderings to be violated. And in that case, I think it's kind of important to be able to handle these scenarios. Plus, I think it's important to have some tests for these scenarios. For example, if I just announce a Fortress update with a hash that has never been advertised or anything anywhere.
Right. Mikhail, what's the state of handling race conditions between various methods in the engine API? Is there anything specified there, or did we leave it as unspecified?
I think that, this example with fork choice updated, it will just return syncing because it doesn't know the payload that is specified as the head. So I think it's pretty, it should be specified and all edge cases should be addressed by the current specification. I mean, so it has meaningful responses in all these kind of cases. That's the current state to my observation.
Okay. Then what we should do, though, on this pass is, as we make any modifications, do triple sanity check that ordering can be handled elegantly.
Yep, and with respect to ordering, there is like the statement in the spec that just says that the fork choice updated must be sent in the same order by CL clients. So that's basically it. So no JSON RFC request ID is used anymore. Just to order the messages, to order the processing of messages.
Yeah,
so it's relevant.
I do understand that the specs clearly state what the order should be. I'm just saying that bugs happen and the clients shouldn't go belly up because somewhere there's a bug in some client.
I get it. I don't think there should be no unrecoverable states that the software will be in. Like if the fork choice update is sent prior to the execute payload, if it happened like accidentally once or twice, it will be recovered. If it happens always, so it will always be in syncing state. And yes, that's the issue. So, but generally, yes, it should be, there should be no like state from which the software can proceed and recover from with the current spec.
So intermittent ordering failures should be recoverable, but persistent ordering failures, you say, likely is unrecoverable.
Yep.
But important to
yeah,
maybe induce that in a Hive or other environment.
Yeah, but if there is the constant misorder in the messages, I don't see like any potential way for a client to recover itself.
Right. Any other testing updates? I know there's a lot of parallel efforts right now, or other just testing discussion points for today.
Could I just ask what consensus clients support starting from a merge Genesis state?
Sorry, merge pre-transition or merge post-transition?
Sorry, merge pre-transition. I guess, are there any consensus clients that don't support starting directly at that fork?
It is specified in such a way that it should be possible. I know that in Amphora, not all clients handled it at that point, so we were doing kind of the progressive forking, but I'm not sure where it stands today. Yasik, I see you unmute and mute. We can't hear you. And I apologize if we've been talking over you for the past 40 minutes. Still no. Thank you. I believe that Nimbus was the one M4 the only one that didn't. So I would suspect we're in a direction where most can at this point.
Great, thanks.
Okay. Other merge related topics, Kintsugi related topics. I know we talked timelines, or we talked like the progression of what we want to do with testnets a bit last week. On the Alcor Dev call. We do have spec updates coming. The semantics of these two calls are probably the deepest thing. There are a couple of other very minor things that will come out, and there's I know an active discussion and hopefully a coming PR on ELCL communication authentication. So I think probably the semantics of these two calls and the authentication are going to be the biggest changes that come. Until that comes out and we get some initial testing going on, Kintsugi will probably remain up. Then another version of Kintsugi, maybe named something else. Then we talk about forking public testnets. So high priority to get these spec changes out and move towards a frozen or near frozen state so that we can get the next wave of stuff done. Any questions or comments on that? Okay. Great. Before, please.
I just had a tangential point. Does everyone already support the Paratrix renaming? If so, could we organize like an update round sometime end of next week, perhaps, so we can just change the configs everywhere? No, as well as documentation.
Yeah, from what I can tell, clients are ready in various states and at least have PRs ready. So we can probably coordinate outside of this call to pull the trigger on it on Tuesday, Wednesday, something like that.
Sounds good.
Okay, Salius.
Yes, I have a few questions. So it would be really great if somebody could collect the information what other clients changed and what basically patched and why they did so during this Kintsugi incident, as it's a bit not clear what exactly was needed to change in the client. So maybe everyone could check this list and see is there need to do the same thing in their own client. Well, that's my question. Maybe somebody could do that. And another thing, so I was thinking that the way EL currently handles forks, it's been interesting from proof of stake point of view, because it looks like in the proof of work it handles forks well. Well, the mainnet is running and there is no major issues. And I was thinking maybe we can change something in the forking, let's say, dynamics or economy, in order to make on a proof of stake level, in order to make it more similar to proof of work. So basically, the first idea that came to me is that in a proof of stake, it appears that the forking itself is very cheap. You can basically, if you are a proposer, you can cheaply, without any damage, let's say, build a block on top of some old blocker. And this is something that is not easy or not cheap on a proof of work side. So basically, the idea is maybe somebody already discussed this. Maybe it's possible to make less forking or the forking dynamics that is more close to the proof of work. So that would make reusing the exact approach that execution layer is using now. So we don't make a problem for execution layer. So was there some ideas like this?
I remember there was some discussion like this. I'm not sure if I think it was in Greece where we had the discussion whether proposing bad blocks would be an offense.
So some penalty or even maybe not slashing as tricky with slashing, but at least some large penalty for making something which is unusual in proof of work economy and which is very let's say tricky for execution layer to handle.
Right. So defining these cases, one, is hard, and two, might induce arbitrary penalties because I happen to be slightly out of sync or on some fork, and I haven't been able to resolve it. So there's.
But that's the same on the proof of work. If you are late, if you are late on the chain and you don't follow it, and you spend your resources on building a block that is not on the latest block, then you are penalized by wasting resources.
Right. I understand.
I mean, I understand that this is very large, very high level idea, and of course it's not complete without all the details. But I was just wondering, maybe there was discussion.
Right. Essentially, if you can include proof that someone built a block that did not make it into the canonical chain, you could potentially penalize for that, to try to induce the forking costs that you would see on proof of work.
Exactly.
Yeah.
But you can do that. This is, I think it's possible. You just have this block which is signed by proposer, and it is pointing to some old block.
So you likely can do that because there is a block roots accumulator, and so you can take the header of the proposed block and you can point to the proof of what was actually in that slot in the canonical chain, and you could potentially decrement the value there. I think one thing that is an attempt to do this without having to directly incentivize that would be the fork choice being an attestation-based fork choice, such that it's it should be moderately cheap to figure out if it's even valuable in processing something, especially with respect to the execution layer. But yeah, it's an interesting exploration. It's not something I've thought deeply about.
Okay, yeah, if somebody wants to discuss further, yeah, we can maybe do that.
Yeah, Marius, with respect to not following the consensus rules, I think that's much more difficult to actually prove on chain without a more maybe advanced snark constructions about the beacon chain execution, which arbitrary proofs about beacon chain execution are certainly not feasible today. All right, let us move on. Are there any other client updates other than what's generally been going on with the merge that consensus layer clients would like to share today?
I would like to welcome Dade, who just joined the team. So yeah, welcome Dade, welcome to the team. Also new
Welcome.
release 30330, and we're gonna drop the user guide, hoping to contribute to client diversity. Yeah, that's it for us.
Anyone else?
Yeah, so for Grandina, we finally joined the testnet just before the crash, and we thought that maybe we caused it, but that was not us. And there we are back again today with 1,000 validators, and looks like it's performing well. Currently, we tested only with Geth, and we will need to test with other combinations. And maybe somebody could comment is if the implementation is working well with Geth, is it likely that it will just work well with others, or most of them needs custom handling?
The short answer is we do find idiosyncrasies and are attempting to work through them and test them such that in a way that they don't appear by accident. But generally, yes, if it works with Geth, it should work with the others.
Okay, cool.
I also think we're at a point where it's pretty stable. So in the beginning, it was more of a hassle to get like the different CLs with the different ELs running, but now we seem to like converge on a common implementation.
Great. Any other updates?
Yep, I guess I can go next. So on the Prism front, we have been working on optimistic sync. We started looking into for choice proposal boost and the new for choice backtest, hoping to get those done by the end of January. And we are also switching our beacon state from gRPC protobuf to a native growth structure, so that will save on memory. And we're also implementing the new Web3 Signer Key Manager API. So the goal is to support a generic GUI coming from the ETH staker effort. We also propose a few more API, few more key manager API point to manage public keys better. And we're on track to fully support Web3 Signer API by the end of January. And we also hire one more person to run. He is our DevOps guy. So if you see him, say hi.
Awesome. Thanks, Terrence.
Right, I will provide some updates from Nimbus. We are also preparing a new release, which is probably going to be shipped today or tomorrow. It's mainly a performance release, but it also ships the key manager API that Terrence mentioned. Interesting thing about in this release is the fact that through optimizing the use of the Nimbus garbage collector a little bit, we were able to significantly reduce our memory usage. And so we are now hovering around 1 GB on mainnet. And we are pretty confident that our next release will kind of provide stable operation always in less than 1 GB.
That's insane. Congratulations.
Other than that, other interesting feature in this release is that we've implemented pretty much compatible validator performance metrics, which are very similar to the ones in Lighthouse. I would say almost 100% compatible. I've noticed that Prism has implemented validator performance metrics on their own. So I'm curious whether there's some appetite for standardization here. So the dashboards of the users can be portable. And the other line of development that we want to pursue very actively is the Light client. I think that was mentioned in the past, we have a server that is compatible with Lodestar. And now we are trying to build a client embedded within Nimbus. There will be a special Light client mode in Nimbus that enables some of the REST APIs remain active, while others, which are not possible, are disabled. But to this end, we really want to see the Light client updates being distributed within the peer-to-peer network. So we will try to propose, to create an implementation that works for Nimbus nodes and to try to propose this as a spec.
Thank you. Anyone else?
Yeah, I can do Lighthouse. Oh, sorry, you go, Adrian.
Thanks. So for Teku, fairly quick one. We've got a 22.1.0 release out, which includes the network config for Kintsugi. So you can just say -- network Kintsugi and off it goes. Also a bunch of optimizations in there. We've been doing a bunch of work on optimistic sync and finding corner cases, stressing get out by pushing some of the limits of what we validate and send to it. And generally getting into that Kintsugi mess. That's been really helpful though. So I think we're starting to find lots of great corner cases in optimistic sync, and I'm feeling a lot better that it's not only viable but getting well understood, and should work out pretty well. We've also been doing a bunch of work on the Key Manager API, which I think James, he was going to talk about a bit, but we've got that behind a dev flag, so you can enable it now in the release build and play with it. The bits we're missing before we enable that are just making sure that authentication is supported and SSL, but that's underway now. So hopefully in the next release, it should be a properly supported feature to have the key manager stuff there.
Excellent. Thank you. And Paul.
Alrighty, so we had a nice break over New Year's. It was good to get a little bit more relaxing break than last year when the beacon chain just launched. So we're going to do a release candidate in the next 24 hours and hopefully a release next week. It's a big release, actually a lot of work. There's some improvements to attestation performance, also networking, and we removed some cases where we were downscoring peers for our own internal errors. We're also moving our slasher database from LMDB to MDBX because it supports pruning and shrinking the database. So we can save a lot of space for users there. I've been working on optimistic sync specification. It feels like it's getting pretty close to being mergeable. It seems like the core concepts of it seem pretty stable, which is nice. I'm going to start working on implementing that in its entirety next week. We worked on a Flashbox proof of concept last year. We made good progress with that, got something working, but we haven't been playing with it this year yet. Michael did some more client diversity analysis. He's also looking at doing a little bit more in that department. And we are ready with Proposer Boost and also the Bellatrix rename. So happy to coordinate on those offline. That's it from me.
Great. And it looks like Marius had a question for you, Paul. Marius?
Well, yeah, it's more for like all the client teams, because right now during Kintsugi the chain databases grew extremely by like 7 gigabytes per day or something, because of non-finalization. And I expected that once finalization hit, then the nodes would automatically prune these old states away, but they didn't. So I was just asking if like people have already looked into this, if this is being worked on, or if some clients already have it. I didn't test all the clients. I only tested Lighthouse, but it seems to me that like that's pretty like a big price to pay. And if we expect,
yeah, we should prune and shrink it. We'll just have to look at why it's not happening. We've done it before. We know it shrinks, so there must be something weird going on.
All right, that's great.
Also, for such, it seems like something like on the order of one state per epoch, one full state per epoch is being written to disk in that case. Are there any investigations to do deduplication of states when non-finality in writing or potentially in like quote archive modes? So just like handling diffs because a lot of the validator set doesn't change. I don't know if this is like a high value item, but I'm just curious if anyone's doing that.
Teku's default mode for storing finalized states now stores them as a tree, so it deduplicates, which gives you really nice fast access to historical API queries.
Nice.
But we still store the full states as snapshots for non-finalized stuff because pruning is really hard once you start storing a whole tree of things and have forks involved.
I see. Okay.
Is this working now?
Yes. Welcome.
Whoa. Thank you. Yeah, I mean, same thing with Nimbus. We actually store everything. We store the validator database deduplicated. Also for recent states, because that one actually doesn't change between forks. So we shouldn't be growing very fast, and we have that nice fast historical access as well.
Cool. So when you do deduplication and you do diffs on historic stuff, that means that you can do a quote archive node at a much lower cost.
Yeah, exactly.
Cool.
Like Nimbus doesn't even have a non-archive mode right now.
Oh, nice.
You always get the full history. It's just sitting there, and it's not that expensive yet. It's going to become more expensive. But the point is that the validator DB trick is very nice because the validators are the same across all forks. So it's kind of like an append-only list.
Right.
And so I forgot to mention actually one of the features of our latest release is a cache in the REST API that speeds up what I call historic traversals. When you request certain information, such as the validator balances, either slot by slot or epoch by epoch, this cache in the REST API speeds this up significantly.
So that's one of the differences with the way Teku does it. We've deliberately used more disk space, and we're storing every state deduplicated but in full. So there's no replay or calculation of those diffs. It's just there's a tree there, and you load it. We can load partial trees there.
Every
So it's a
slot
different
or every
trade-off.
epoch?
Every block, effectively.
Okay, well.
So it's 200 gig, I think, or so. So it's pretty chunky in terms of what it stores for the entirety of mainnet, but you can query anything instantly, which is quite nice.
Right.
And this 200 gigabytes is for this states tree, or there is something more?
That's the whole database. So it's got every node of every state from each block, right through history, plus all the blocks, plus whatever other little bits and pieces we need to store. So that'll be ETH1 data and so on, but state is the main one.
Do you know what the percentage or what the number of gigabytes is for the state tree only?
No, I don't. And Ben's just corrected my numbers. Apparently we're using about 350 gig. I'm terrible with numbers, so you never trust me.
Okay, but
so it is big.
It looks a bit much, I would say. I don't know. I mean, it would be great if you get a more accurate number of how much is for the state tree only. That would be interesting to hear. Offline,
well,
I mean.
Yeah, we store everything except the finalized states in under 20 gig.
20
also.
gig. Okay.
Like it's quite small. So pretty much the entirety of that is all the state trees. But it's designed particularly for people like Infura, whether you're having quite random access to states from all over the chain and quite a lot, and you're prepared to throw some disk space at getting it quick.
I mean, okay, but this state tree alone, it probably. I mean, there are not that much of diffs really. I'm just thinking, you know, it should be if you don't if you have like a full deduplication and you don't store anything extra. I don't know, like maybe you calculate some rewards. Let's say for each state you cache some data rewards or something. Then this is extra data. But the state diffs, I think they are pretty small. And if you just have a state tree, which is fully deduplicated, it should be really small, not 100 of gigabytes or so.
Yeah, I mean, there's a lot that changes in there. So it depends how you store it. The actual data that changes is quite small, but to then track which part of the tree that data changed in and kind of have a patch format, you wind up potentially having quite a lot of overhead if you do completely full deduplication. So we store it as a Merkle tree. It's very kind of old school ETH1. And wherever the nodes are the same, we don't need to store it again, but we can walk that Merkle tree down and load just a part of the state. So if you ask for balance of one validator, we walk the Merkle tree down. We've optimized that to reduce overhead by being able to compress and store, 5 layers of the Merkle tree in one go. So then we only have to look it up once. It saves us some disk reads at the cost of not deduplicating as much. And so we found that 5 number by doing a number of experiments, and that actually gave us the smallest disk space. If you totally deduplicate, you wind up with more overhead as well. And so you wind up using even more disk space.
Okay, clear. Because the key thing is that, like in Grandina, we have very fast taste transition, and we started to think, is it really worth to optimize that much on deduplication when we can transit the inner states pretty fast, and it looks like it will be always a trade-off between the disk space anyway and between computation speed. But that would be interesting if teams could provide their numbers, like how much the state tree takes on a disk, and what speedups, actual speedups it brings. That would be interesting to see. As it looks, that the degree of the duplication or the extra data is different in different implementations. It's not the same on all the clients. It looks so. That has this the duplication stuff implemented.
Okay, I think we shall.
There is
Go on.
one more point I could share on this topic, which is that we've been playing around with this idea called era files. So an era is basically 8,000 blocks of data. Why 8,000? Because that's the number that appears in the number of root tables in the state, and it's about a day of data. So if you take mainnet up until now, we've had about 340 such eras. And if you count the amount of space that takes, so in each era file, what we do is we put all the blocks, all those 8,000 blocks, and one full dump of the state. So basically, from any era file, you can just start from that point in time as say a checkpoint sync or whatever. If you take the full history of Ethereum to date in this era file format, which is just a flat file with blocks and then that one state, then you end up with about 30 gigabytes of data today. And that's just raw, no indices, no smart things.
Nice. And I do think it makes sense to get those changes into that next fork that will be coupled with Shanghai.
Oh, you mean the block root?
Yeah.
That would be nice. But this is separate, actually. This is just like...
right, you don't actually need the change in there?
Not for the era... Well, for the era files, it becomes a lot easier.
Right.
But this is kind of like... The nice thing about this format is that we can generate like an era file every day, and it's like a fully verifiable format against any later state, more or less. And you can distribute them through torrents or whatever. You can share them with your friends. You can serve get block by range requests from them. They're just nice and easy to work with. And yeah, the block range thing would definitely make them even easier to work with, like for lots of reasons.
Cool. It's interesting to see implementations, what they've been optimizing, and kind of the end user they're catering to diverge more and more. I think that's a good thing. Okay. Anything else today? Any research updates? Any general discussion points?
Yeah, maybe an update from my side. Many of you probably saw it that I published sort of a draft for some changes to the sharding that should greatly simplify the design. So I don't know which teams are currently already or have done work on implementing the previous sharding spec. If you are on that, then it might be worthwhile pausing that for the moment and having a look into the current draft PR that's up. It's a very early stage, but it would still be interesting to get feedback and to get people to look at it at this point and see what they think of it. I think it's a great simplification. Will make it much faster to implement.
Yeah, awesome. And if you're listening to this call and you're a networking whiz and want to work on some fun DHT stuff, get in touch with us.
Also, if you know something about DHTs, then that could be very helpful for us, because I think most of us don't have much experience.
Anything else? I did see George on our team dropped a pretty comprehensive SSLE single secret leader election proposal on ETH Research today. If you want to check that out, should be some good content. And if there's nothing else, we're going to close. Going once. Going twice. Okay, thank you. Like I said, high priority to get any spec changes in ASAP so we can keep the merge moving. Talk to y'all soon. Thank you.
Thank you.
Thank you. See you.
Thanks, Danny.
you.
Thanks,
Thanks,
all.
everyone.
Thanks, Danny.
Bye-bye.